Good morning, everyone. It's a pleasure to be here in Washington. It's one of the first in-person events in a while. So I think the previous presentation is a really nice segue into this discussion. And just to kick things off, I guess I'll wait a second for the slides to load. But for those who aren't familiar with the energy sector, right now there's significant change underway. In the energy sector, we're moving from a reality where in the past, our electric grids had been large, centralized, largely fossil fuel-based power plants moving one direction to power our homes, our offices, our buildings, our industry. We're quickly moving to a reality which is already emerging around the world, where we have many, many more devices and assets both producing and consuming electricity. For example, we have solar panels, we have wind turbines, we have batteries, we have electric vehicles. And in this new reality, we have the potential to build grids that are more resilient and be able to withstand major weather events, to be able to withstand new business models and new needs as we move toward clean electric grids around the world. We're seeing significant investments in new physical infrastructure to make this transition possible and achieve a combination of regulatory and policy goals in terms of meeting the needs of investors, meeting the needs of you and me as customers of utilities or stakeholders in communities around the world. And with this transformation, while there's been a lot of investment in the physical infrastructure side of things, there's not enough investment on the digital infrastructure. And this is where the context for where we see blockchain coming into the conversation in energy. So, as I said, the previous session was a nice segue into this. At EnergyWeb, which is a global nonprofit organization, we build open source decentralized tech for the energy sector specifically. We see the combination of digital identities, more specifically decentralized identifiers, with public blockchain as a critical combination of basic technology tools to support the transition toward clean electric grids. To provide a more specific example, for those who live in the DC area, let's say you're a Pepco customer, you have a Tesla, you have a solar panel, you have a battery. Right now, you'd have to enroll in a whole bunch of different programs, each with their own registration process. They don't necessarily connect. They might have different user interfaces. And then, this presents a lot of barriers to entry. It makes it not as easy to participate in all these markets as it might otherwise be. And with decentralized identifiers and blockchain, you can create a single identity per customer for you and me, in this case with Pepco here in DC. You can assign one digital identity for each of the devices you own, anchor those on a blockchain to establish its existence, some basic details about it, and then make it really easy, you're thinking of this as kind of a digital passport, for you to plug into any single market you might want to participate in, whether that's selling clean electricity, whether it's providing flexibility for the grid when it's, we don't want to turn on a natural gas plant at a certain time of day in the summer. And we think this basic digital infrastructure is really important to support the transition to clean electric grids. And I think what's interesting about this is it quickly scales up from the individual level to communities, to states, to regions, in terms of making sure that as we move toward clean electric grids, every single device and every customer can easily plug into any clean energy application. To make this a little bit more concrete, at EnergyWeb, we're working with companies around the globe who are making use of public open source decentralized technologies to support the energy transition, and they're really focusing in primarily two areas. The first area is around traceability, meaning knowing where your electricity is coming from or your energy is coming from. And in this case, there are various companies between North America, Asia, Latin America, Europe, that are looking at building tools to make it easier to buy and sell renewable energy or clean fuels, where the role of blockchain, again, is creating identities for each production device of renewables, anchoring that on a blockchain. When there's a change in ownership of the renewable energy from a seller to a buyer, documenting that, and again, quickly ramps up into large-scale applications to support those who want to buy and sell renewable energy or clean fuels. The other area that we're seeing a lot of traction is around grid flexibility. So what this means is the ability, for example, to tap into batteries for it's windy at night. So as countries move towards, say, adopting more wind power, they need to make sure to store it overnight. and then tap into it at different times of day. Similarly, when we all go home on a hot summer day, we all turn on our air conditioning. We need to make sure we have sufficient reserves or the ability to power down other devices at those times of day. And this is where, with digital identities and blockchain, we can establish certain business logic or market rules to different devices and customers to do certain things at different times of day. All that is documented on a public blockchain. And we're now seeing significant traction at large scale, for example, in the state of California, in Australia, and across several European countries. We're seeing major grid operators actually testing this technology, where at the end of the day, going back to that original image, it makes it possible to manage the significant number of new devices that grid operators have to keep track of, make sure the lights turn on, and make sure they turn on with renewable fuels and battery storage and efficiency rather than large fossil fuel-based plants. One other topic that I thought might be interesting to this group is the Energy Web, as well as two other nonprofits, Rocky Mountain Institute and the Alliance for Innovative Regulation. We together created a new initiative. It's a private sector-led initiative, essentially to make sure that all blockchain-based and crypto-based industry is powered with clean power. As I'm sure many of you are aware, blockchain in general consumes notable amount of electricity. Of course, Bitcoin and Ethereum are the elephants in the room. We're taking an effort to power all crypto mining and all the businesses built on top of this to essentially push the clean energy industry forward. We know that the crypto sector is one that's keen to adopt new digital technologies quickly and early. And so essentially we see the crypto sector as early adopters of blockchain-based technologies in the energy sector. And our goal with this crypto climate accord is to essentially remove the point of criticism about the energy topic, change the conversation to say that the crypto sector, if we're successful, has become the largest buyer of renewable power on the voluntary market. And the way that we're trying to get here is to build tools to make it easy to figure out what is the energy use of a given blockchain or cryptocurrency or a specific transaction. How do we make it easier to procure renewable energy based on your energy use? And that goes back to some of those examples I mentioned before in terms of traceability. And then lastly, how do you prove it? And this last point is one that's really coming up in a lot of conversations here in DC around ESG investments or regulation, or where ESG stands for environmental, social, and corporate governance. There are a lot of funds in general out there outside of the blockchain space that are guaranteeing certain environmental and social impacts. There's not a lot of standards or proof that that's actually delivering. We're trying to position the crypto sector to using blockchain itself to verify the environmental credentials of what the crypto sector is doing to deliver this, change the conversation, and again, position the sector as a leader for the rest of the financial sector to follow. Thanks for your time. I don't know if I still have time for a question or two. Looks like we do. So looks like there's two questions, so we probably have time for those two.
Yeah. Nabil, 1 second. Here. Who are you and who do you represent?
My name is Nabil Malik, and I've been in the crypto and blockchain space for about 6 years. I run a private consulting practice that we build miners and help set up cryptocurrency portfolios for our clients. My question is, Bitcoin gets attacked hard for consumption of electricity, but the city of Las Vegas consumes more electricity than all of mining in the world. I mean, the internet consumes electricity, gas, your house. I mean, why do we get attacked? Why does Bitcoin get attacked?
Yeah, good question. So we don't think the point of criticism is productive. At the same time, every sector has a responsibility to decarbonize from our perspective. And so we want to take this criticism, turn it into a positive example to show how the crypto sector is solving the many problems that the people in the crypto space say they're solving. And we want to use the technology to verify the credentials, not just trust, like so many those out there say that they are making progress in renewable energy. But I mean, you're right to say that other sectors consume more electricity. At the same time, let's show the world that this sector is doing things better and one that's worth following.
Thank you. Who are you and who do you represent?
Hi, morning. I'm Petra Hansen from the Embassy of Sweden here in Washington. Thank you for your presentation. Could you tell us a little bit more about this crypto climate accord that you have up on the screen? How long has it been around? Who is the who's pushing it, and how far has it come? Thank you.
Sure. So it started in the late spring of this year, so just a few months ago. We now have about 160 or 170 companies who have raised their hands saying, yes, we support the objectives of the Accord, where the objectives are decarbonize the entire crypto sector by 2040, and over the next 5 to 10 years, build all of the technical tools necessary to deliver proof of green crypto. So essentially, what we're now doing is we're building open source technologies and good practices and standards where it's easy for you and me as a crypto investor or holder, let's say, for a crypto exchange or for a crypto miner to know what they should do in terms of renewable energy, procure the renewables or carbon offsets, prove that on a public blockchain, in this case on the public energy web chain, and use that to support their environmental credentials. We have, for example, we published the first showcase of these technologies about 2 weeks ago. If you're familiar with the Filecoin blockchain, which is for decentralized data storage, we worked with Protocol Labs, the R&D lab for Filecoin. We're building tools with them over the next year and completed the first showcase where a handful of Filecoin miners figured out their energy use. They then looked for renewable energy on a public search engine for renewables that we've built, where all the supplies have been tokenized based on the data from grid operators. So again, solid data from the grid operators, documented on chain. Filecoin miners figure out how much energy they need. They find the options. They buy renewable energy. They document that transaction on chain. And then what's interesting from an incentive perspective, they then report their proof of renewables to boost their reputation in the broader Filecoin reputation system. This is not so different than solutions we're now starting to scope with a number of Bitcoin green mining pools and Bitcoin miners, where the idea is let's make it easy for any Bitcoin miner to use these open source technologies Energy Web is building to verify their use of renewable energy or procure renewable energy if they're not already, document on chain, join a green mining pool, attract more ESG investments, address local regulatory and policy concerns. And again, using the technology to solve the point of criticism that this industry is facing. I think we're probably at time. Thank you.
All right, thank you, Doug. Next, we have Tara Sue Miller.